Alright guys, so today we're going to talk about surface area and volume of two other types of three-dimensional shapes. First I'm going to start with pyramids. So what a pyramid is a three-dimensional shape with one base and, over here, no, one bottom, but kind of one base that is unique. And then all the stuff that goes around are not rectangles anymore, they're triangles. So unlike a prism that has two bases and rectangles around, a pyramid, like, the ones in Egypt, it's fine, you can think of it that way, has one base, so one shape that is unique, and then triangles around. So like you want to be able to tell the difference between something that's a prism and something that's a pyramid. I think it's kind of easy because a pyramid always comes to a point. But also there'll be one shape that is unique and then a bunch of triangles. Now it could be that they're all triangles. And then you kind of have to be intentional about what you pick for your base, but usually it's the one that's different. Unless they're all the same, then you can pick any one you want. Okay? So same sort of little sheet that we had here with the prisms, but with pyramids. So for surface area and volume, we want to take a look at our three-dimensional shapes and like how we find those, like by using our formulas. Now again, we have to pick our base. So here, the bottom is our base because that is a square and then everything else are triangles. So here's your base. And kind of two things are important when it comes to a pyramid. The height of the pyramid is important. So kind of from the very center of your base to the point is the height of it. And sometimes I need to know the height of the pyramid. But I also need to know something about those lateral faces. So the triangles that go around, you notice I also have this line drawn right here, which maybe I'm gonna highlight. This line right here. And on that line, there's a box showing that it is perpendicular, but it kind of doesn't look like it because it's slanted. But what it is it's the height of this triangle, and all the triangles that go around your pyramid are the same. So it's really the height of all the triangles on your lateral faces. So that height right there has a slightly different name. It's called a lateral height, which we usually denote with a cursive L, so that it doesn't look like a 1. So fancy cursive L for lateral height, because it is the height of your lateral faces. Okay, so similarly here, if I pick this bottom triangle, the equilateral one, to be my base, that's important. But then we also have the height, so from the bottom, like the middle of the bottom base to the point of the pyramid is your height. It's kind of this, it's not really part of the pyramid, it's sort of this invisible height that kind of just drops down. It's not really an edge or anything, but it's important for some things. And then again, we have kind of going along that lateral face right here, your lateral height, which is also important. So we kind of have to juggle two heights with pyramids, which makes them a little bit trickier. Now another pyramid that we're going to look at is a hexagonal pyramid. So when the base of my pyramid is a hexagon, we have our invisible imaginary height right here from base to point, and then along the edge on one of those triangles we have our lateral, I forgot the little boxy down there, that lateral height, which is also important, which you can hopefully see now why it's important, because if I take a look at surface area formula, hopefully you notice we have that P for perimeter, we have B for area of the base, but we have that fancy L now, which is that lateral height or slanted height, which I'll sometimes call slanted height because it is slanted, so it's kind of weird. Also half. So that's how we find the surface area. We find the area of the base, and then we add on half the perimeter times the slanted height, or the lateral height. And it's half the perimeter. Like, the half comes from the fact that you're not rectangles around, you're triangles around. And when you're finding the area of triangles, you have that half base times height. So that's kind of where the half comes from. And similarly right here, if I want to find just the lateral area, so the area of all the triangles around, you have everything but the base. Okay, so that kind of makes sense. Although lateral area is not super important. Like, I didn't do any last time with lateral area. I don't know if I'll do any with this time. Okay, and then volume, just like the last one, we're going to find the area of the base, times it by the true height, so not the lateral height, the true height, so from bottom to point, but we're going to take a third of it, and that's kind of because like some chunks got cut off when you made it come to a point like that. Specifically, 2/3 of it, 2/3 of that volume was taken off. You're left with a third of that volume when you sort of make everything come to a point like that. So that's kind of how that works. All right, so we're going to try a couple of those, and then we're going to talk about one other type of three-dimensional shape, and then we should be good. So I'm just going to try one of each of these. I'm just going to try all these ones on the right here because it's a little bit easier. So if we're going to find the surface area of this square, we're going to assume it's a square. It's a really bad square, so sorry about it. Square pyramid. Surface area of a pyramid is area at the base. I have one base now, plus half the perimeter times the lateral height. So that's why I like to write it in this form, because a pyramid has one base. So I know that this is the formula for that. Versus last time when we were talking about prisms, they had two bases and it was 2b. So that's why I always put the b first. It just helped me remember the formula better. Okay, so in this picture, our base shape is a square. And so to find the area of a square, we do side length squared. So 16 is on that side. And again, I know it's a really bad picture. Just trust me, it's a square. Plus half the perimeter of the base, which to find the perimeter of the base, I can do 16 plus 16 plus 16 plus 16, or I can just do 16 times 4. Times the slanted height, which they've actually given me here, that the slanted height, because that's what the L next to it is identifying, or the lateral height rather, is 10. So I have that. So didn't have to solve for anything, I just have to simplify my numbers. So 16 squared, I'm going to get it wrong. I'm just going to calculate 256. Plus, now over here I can take half of whatever I want, so I'll take half of the 16. Then 8 times 4 is 32 times 10, so 320. Add them up for 576. So surface area, is 576 units squared. Okay, then if I want to find volume, volume is 1/3 area of the base times the height. Sorry, so it's not cramped. Got 1/3 times. Now I found the area of my base already, or kind of. It was 16 squared, which was 256, so I can just write that down. And then times the height. Now I don't have that number. The number that they gave me was the slanted height. But I can get it because I know that the true height is right in the middle of the square. So right in the middle of the square is kind of where the diagonal is cut in half, but it's also like halfway from 16 to 16. So this length right here is 8, which is helpful to me because the slanted height, this middle length or height or apothem, oh my god, and the true height, they all make up a right triangle. So kind of the right triangle you're looking at is the slanted height, or the lateral height, the true height, and the apothem. Now the slanted height I know is 10. The apothem I can find it's 8. And so then I can do the Pythagorean theorem to get the height, where the slanted height is your hypotenuse. So we got 10 squared equals 8 squared plus null squared, which is going to be 100 minus 64, which is 36, and then square rooted is 6. So my height is 6 Oh my word, it's amazing. Okay, so then I can take a third of whatever I want, and 256 is just big. Like, I'm just going to take a third of 6. That's 2. And I'm taking a third because, like, we're dividing by 3. And then doubling 256. Oh my god, I'm being so lazy. 512. I know it. It's 512. I don't need my calculator. It's 512. Good job. That's right. Pat on the back for me. Okay. Next, we jump down to a triangular pyramid. I know it's a pyramid because it comes to a point. If I find the surface area, it's still the same as the last one. Area of the base plus half perimeter of the base times slanted height. The base shape that I have this time is a triangle. So to find the area of that, I'm going to do half base times height plus half the perimeter of the triangle, which 42 root 3 is the side length. And so I have 3 of those because I can see that it's equilateral. So I can do 3 times 42 root 3 to find the perimeter. And then the slanted height, which I don't know. So that's a bummer. I'm going to leave it out for now. Okay, when I go back and think about finding the area of that base. So just to be clear here, the base is kind of this bottom triangle that we're looking at. I could do a couple of things. I can do half base times height. I could also do half apothem times perimeter, which, I don't know, let's do it. I already have perimeter, why not? So let's do half apothem times perimeter, because I already got perimeter. It was at 3 times 42 root 3. So then I just have to find my apothem. And I need it anyways, because it'll help me find the slanted height. So 3 times 42 root 3 times slanted height. Okay, so if we think about drawing in our little right triangle right down here, to find that top angle, remember we did 360 divided by 3 because you got 3 sides, and then split in half again, the apothem. And so you're on a 30, 60, 90. Now that apothem also split the 42 root 3 in half, so 21 root 3 is really how long your long leg is, which is where the root 3 is supposed to be. So to find that short leg, or the apothem, you just take the root 3 off, and it's 21. So now I know that my apothem is 21 units long. And then I got 3 times 42 root 3 for the perimeter. Now I have to go back to my triangle and find that slanted height. And I can do that because I have the right triangle that goes up into the pyramid, where your apothem is 21, so that's a leg. Your true height is 28, and then you can find the slanted height by doing the Pythagorean theorem. And the slanted height is always your hypotenuse, so 21 squared plus 28 squared equals hypotenuse squared, or in this case your slanted height. Now those are big numbers, so I'm definitely going to use my calculator for that. So we'll have 21 squared plus 28 squared, and then square rooted. Oh my word, my thing is locked. Super annoying. Square rooted is 35. So my slanted height is 35. Then we just got lots of numbers to multiply now. So I can take half up here of whatever I want. So I'm going to take half of the 42 for 21. So then I got 21 times 21 times 3. So 1323 root 3 for that front number. Plus on the second number, I'm going to take half of 42 again. So 21 times 3 times the 35. So 2205 root 3. Oh, and they both have a root 3, so now I can add them. So I'm going to do 2205 plus the 1323 for a total surface area of 3,528 root 3. Oh my god, what a hot mess. Units squared because it's area. Oh my god, I hope volume's not as terrible. So volume is 1/3 area of the base times height. And luckily I already have the area of the base because I did it right here. So it was that first number, that 1323 root 3. And I already have the height. Oh my gosh, bless. It was 28. Okay, I can take a third of whatever, and that number's big. But I don't know if I can take a third of it. I know I can take a third of 28 though, right? Can't I? No, I can't. Can I take a third of 1323? Oh my gosh, I hope I can. So 1323 divided by 3. I can, it's 441. And then I'm going to times that by 28 and then stick a root 3 on the end. So times 28. Oh my gosh, 12,348 root 3 units cubed. That is a big old pyramid. Alrighty, last but not least, we got a hexagon here. So, surface area. Area of base plus half perimeter times slanted height. I'm going to skip this one just because it's very similar to the last one. I think you'll be fine because I want to move on to spheres. Okay, so the last three-dimensional shape we have. Now, a cylinder is really just a low-key prism with circular bases. Circular bases. Because really what I'm doing here is 2 times the area of the base, and then plus perimeter of a circle is really circumference times height. Here's area of the base times height. So it's really just a prism with circular bases. A cone is really just a pyramid with a circular base, with a circle base. And I have that formula here. We have half PL, which perimeter is circumference, but I took half of it, so that's why the 2 pi r is not there. That's why the 2 is not there. Times your slanted height, and then plus the area of the base. And then here they're dividing by 3, but that's just like taking a third. So you can see how it's the same, because we have our area of the base, which is a circle. The only thing that's really new is a sphere. And a sphere is just like a 3-dimensional circle guy. So circles all around. It's like a globe. It's the Earth. Look at that. So I find the surface area by doing 4 pi r squared. And then I find the volume by doing 4/3 pi r cubed. Or again, r is just radius. Radius always has to go from the center of the sphere, the very center, out to an edge somewhere. So if we try that one, oh, look at that, being super sneaky. So to find the surface area of a sphere, we're going to do 4 pi r squared, which they haven't given you the radius. The circle, excuse me, the circle that goes around the biggest part, so if you think about the Earth, kind of the circle that makes up your equator, or the prime meridian if you're going the other direction, that circle is the biggest circle that you can have because it goes about around the biggest part of your sphere. And so that circle has a name. It's called your great circle. But, well, that's important because like in the great circle you have a radius and you need the radius. But they haven't given it to you. They've actually given you the area of your great circle. But that's helpful because I can find the area by doing pi r squared. So I can find the radius by dividing pi away on both sides. And then square rooting to get that your radius is 7. And so the radius of the circle and the radius of the sphere is 7. So I can find the surface area of the whole sphere. So kind of like what makes up the Earth's crust, by doing 4 pi times 7 squared, which 7 squared was just 49. And then I'm going to times that by 4 because I want to leave pi as part of my answer because I want an exact answer. So 4 times 49 is 196 pi meters squared for surface area. And then to find volume, we're going to do 4/3 pi r cubed to get the volume of a sphere. Did I get that right? No, I felt like I forgot something. And the radius is still 7 because we're still in the same sphere. So got 4 over 3 times pi times 7 to the third. So I'm going to do 7 times 7 times 7, so 343. Now, the fraction can be weird, but you kind of have two choices. You can divide by 3, or you can times by 4 right now, and then you just have to do the other one. So I always see if I can divide that by 3. So like, will 3 go into 343 evenly? And it will not. So since I can't divide it, I'm just going to times the 4 and then leave the thing over 3. Because if I can't divide by 3 now, I'm not going to be able to divide by 3 later. So I'm just going to leave the volume as 1372 over 3 pi meters cubed, so that I have an exact answer. If I divide the 3, I'm going to get a decimal. If I times by pi, I'm going to get a decimal. And I don't want any of that, so I'm just going to leave that. Alrighty, and then we'll try this last one here where it kind of has you working backwards. So a sphere has a volume of 7,776 pi meters cubed. Find the surface area. So since they've told me that the volume is that 776 pi, I can set that equal to how I find the volume of the sphere, which is 4/3 pi r cubed. And then we just want to solve for the radius because I need the radius to find the surface area. So this one is interesting because we're going backwards. So I'm going to divide the pi away. Get rid of that. Then I'm going to get rid of that fraction because I'm trying to get r alone. So I'm going to multiply by the reciprocal. Cubed. Okay, so now I got to do 7776 divided by 4 and times by 3, which is 5,832. Now normally when I have an exponent, it's a 2, and I square root it. But we also have this thing called a cube root, which I don't know if we talked about too much, but you can cube root by putting a little mini 3 in there, and I can do that on both sides because a cube root will just cancel out a cube, so that r is alone. And your calculator, so if you're on your iPhone, will do that as well, like if you turn sideways here. So I have that 5,832 up. I don't want to square root it, but I can cube root it. It's 18. And that's because 18 times 18 times 18 is 5,832, so that kind of makes sense. Okay, and that's important because if I want to find the surface area of the sphere, I needed the radius, because to find surface area we do 4 pi r squared, where now we know our radius is 18, so we're going to do 18 squared, which I literally just did but forgot, so 324, and then we're going to times that boy by 4. And not times it by pi because I don't want a decimal, so I'm going to leave pi there, meters squared. So kind of a fun little backwards problem. So guys, I didn't want to make the video a million hours long, so hopefully you feel like you can figure out the cone and the cylinder. I think you'll be able to, but let me know and I can upload another video if we need to. Good luck!